Thank you. Yeah, as mentioned, I'm Jan Klemkow. For those who don't know me, maybe the most of you, I'm a software engineer who made my master degree in engineering and work as a software developer at a software company in Munich called Genua. Maybe some of you heard of. I'm addicted to OpenBSD, and I use it since 3.9 and contributing a couple of changes a year since 5.0. And in this talk I will show you the infrastructure behind bloom.genua.de. How many of you know about this these website and the regression tests or saw it? Okay, a few, if you're not. It's simply it gets some attention on the internet, especially on Twitter and in the OpenBSD core developer community. It's simply just this website. It's made of my colleague, and he used this infrastructure I showed you today. And I will list some words on it. This website shows two things: the run of the regression tests and the results. You can see here tests. You see these tables with the different regression tests, and if they pass or fail. And we had another back. Yeah, and we have these performance tests, and I will lost a few words for these. Okay, this is too large scaled. And there are some performance graphs we do regularly. So let's begin. First of all, the performance tests, just to show you what they're, how they're made of. We have a testing lab in our company. Just a server room with lots of hardware, and we using for the performance test our own product hardware. We make firewalling products based on OpenBSD for application level gateways and layer 3-4 routers. And we use our greater powerful machines to make these regression tests, and it's pretty simple. We use two or several nodes based on GNU Linux because of the better performance of these machines as a source and a sink system. And we interconnect them with a 10 gigabit link to our product hardware, where we don't boot our product system, which is a highly modified OpenBSD. We just for these tests we use just the snapshots every night, install an AMD64 system, and make an iPerf TCP throughput test with routing and with RelayD. And we have an IPsec test where we have two machines, and we measure how much the throughput is through both machines if we have a middle line with IPsec. And it's just from several Linux nodes, the iPerf combined in TCP and in UDP, and you see the graphs on the website how they are changing over time from night to night, from snapshot to snapshot. Maybe some days missing in the graphs, then something bad happened. Patch day or something, and then something bad happens. This is possible. So don't rely on the dates in the graphs. There could be some missings. So now to the main part. The infrastructure which is used for the regression test. I started 2 years ago, but not to make regression tests. My colleague Alexander uses for the regression test, but I actually had in mind to make diff testing easier. What happened is in 2011 I started developing a little tests, or not little tests, little diffs for OpenBSD and sent them to the list. And one reply I got was, "Oh no, this won't compile," or "This has this and these problems," or you send a port and you get back, "You're missing some dependency." And this is because most developers use their own notebook to develop the changes and to test them. And actually, or if you make, when you make ports and you're missing a dependency, you don't get it because it's installed in your system, because it's your daily business system you're using, and you can't wipe everything from it and make a clean test. And so I studied about how to make a simple infrastructure that I have a machine by side I can use to wipe and install, and then make my test on it. So you can make clean tests for one diff. You make clean tests on one system, and know if a dependency is missing or if something else goes wrong, or if you have the problem, you really fell into some bigger problems, maybe you fell into GDB and have to debug it, and it's pretty annoying if you do it with your own notebook, where you have to read 2 mails and you have to read the source code in parallel or surfing and something like this. So this is pretty critical, and not everything could be done in a virtual machine. And then I started thinking about how we can make it something better, or how can I build a system for myself to better and cleaner testing of my own diffs. And fortunately, we have a nice lab in our company, which is just for customers, not for customers, for employees, to testing with open source technology. It's called the OpenBSD lab in our house, because mainly developers are there who testing some OpenBSD stuff within it, but there's also other stuff. There are some OpenBSD forks of some employees from us who just playing around with the source code and making something different and bring something out. And what I've done is I took a machine and I make some automatic installation, and then I saw, oh, there's a way there's a way where I can get it automatically. And from over the time of the last 2 years, I developed a pretty good working system to automatically install a new machine. And then Alexander came to me and said, hey, I would like to run the regression tests on it, because he don't have hardware, and I have this slightly working infrastructure, and he was the first customer of this new system and tested heavily. And I show you this infrastructure. In the main infrastructure are these yellow computers down there. These are pretty old machines. These are machines. I think in every IT company there are some old machines laying on the ground in the corner and nobody cares of. And exactly these machines you can get without any question and start playing with it. And so we integrated into this infrastructure. First there was just one, just for me, and then Alexander came to me with a special requirements, and one of his requirements was I want to make path MTU tests. So he need 4 machines with 3 cables on this. That's the reason why the first 4 machines are interconnected with a red cable, so that he can make this kind of test. The infrastructure is beside of this pretty easy. It's just every machine with every interface is connected to 1 gigabit switch and is behind these test master node. This test master node is part of the lab network itself and has an outside connection to the internet, and it's reachable from the outside. I plan to make these computers really isolated. The test machines itself are not connected to the internet, they're not routed. They just have access to our internal OpenBSD mirror, which we use also for our internal development in the company, because it's much faster to install from this, or to install the packages from this server. If we would install it from the outside, it costs a lot more time. That's the reason why I use this, and this is interconnected via RelayD running on the test master itself. The test master itself has some other infrastructure connected. I found a power switch, just a power supply, which is switchable via a serial connection. Nowadays, we upgraded to a power supply switch, which is switchable over a network. And the test master is capable to switch every machine on and off. So if you really screwed up, if you're on a remote session somewhere else, maybe in Paris, and you screwed up your machine, you can at least you can switch off the power and turn it on again if nothing goes on. And more important infrastructure is the serial connection. In the test master, there are some multiple serial PCI cards in it, and we have and every test system has these serial connection. So if you make some kernel tests, or if you try to reproduce some kernel bugs, you can after you have reproduced it, you can debug this thing in the DDB, which is quite annoying if you don't have serial and you try to remotely debug something or debug it via VGA. And it's via VGA is horrible because you can't really copy some messages. You everything have to type it by hand, and so it's quite comfortable. The regression tests itself don't run on the test master. The test master is just the basic infrastructure, and it's the interface I provide for myself and for Alexander and for another developer who use it. And the test itself and the website I showed before run on the Bloom machine, which is bloom.genua.de, and this machine is also connected to the outside world and have public access. And from these machines on, every night, these machines use my interface to automatically install the first machine or the first two machines and run the regression test on it. And some regression tests require that it reaches the OpenBSD test machine 3 and 4. So that these machines are just alive, and the first two get automatically installed with a fresh, clean snapshot every night. How does the interface look like? The interface I thought, which is pretty nice to me at least, is you just have SSH. So if you have SSH on your computer, you could use this kind of infrastructure. You just have to mention the computer on which you want to run your tests as a user, and then just SSH the machine at the test master system and then the command. If you type nothing, you directly get to the serial console, and you can interactively typing into it and have direct serial access. If you want to install the system, you just type install or upgrade, just upgrade. Upgrade is a really pretty nice feature if you have some configuration files and try some stuff and have some greater diff and want to upgrade them. If you make a clean install, you wipe everything and you lost your configuration, so you can keep it. But if you really want a clean test, then you should make install, and the hard disk is wiped during the installation process. To don't get in conflict with other users in parallel, I have this lock and free command, so you can lock your machine that nobody other can install, upgrade it, or nobody other is able to switch the power off and on or cycle the power thing. The power supply. And it's pretty, it's the interface, and you have nothing to new more than this. And in the background, which I show in the next slide, there are some infrastructure I built, but just with simple shell scripts. Let's look what's happened. First, on the test master system, there's an SSHD configured, which knows that the users for every machine, for example here the OT1 has a force command. Forwardings are forbidden, and you're allowed to open an SSH tunnel to the machine, so that you're not if you have to type a lot and have a lot of debugging on the machine, it's not that annoying because of the slowly serial access. You can open multiple SSH sessions when you first connect to the console and take an SSH tunnel with it, so you can locally forward to the SSH ports of the machine, and you can fastly typing on it and debug your stuff or testing your stuff. So what does happen in the run command? The run script is just simple shell script. where I pass these commands: console, on, off, cycle, and the rest. And it starts the console program, and the serial lines are managed by a conserve. I don't know, are you familiar with console management? Conserve is a daemon which handles serial consoles of different types directly over phone line or over a serial card in your computer, or over USB or over telnet or something else. This daemon managed all this stuff, and it had a client which is called console. And if you type console and the user, you're directly connected. You're forcibly connected to the console via these infrastructure, or via these daemon. And if you type the on-off switches or the cycle, then a shell script is started with just send a packet to the, or make an HTTP request to the switchable power supply, and then it switches the power supply for this machine. So it's pretty easy. How the conserver is configured to limit the access to the different machines. I limit the access of all the OT users, so they can just have a read-write permission for its own. Here, for example, is the snippet of the configuration. You see, we have these cards. Every card has the same baud rate, and the read-write permission is just for the user of this machine, and they have directly access to the device. And yeah, and this limitation is important, because if you don't limitate the access, then the user is able to connect to run serial access. And there are some shortcut commands where you can maybe switch the baud rate if you have to, or you can send a break message if you want to. But you can also switch the console to another serial access line. And to limitate this, that nobody other can switch, that the user can switch between the lines, you have to limitate the access, and that's it. So it's kind of secure. To give authorization access, it's pretty easy. You just have to give me your SSH key, or the developer can give me his SSH key. Here's, for example, our both keys in the authorized key files. And in front of it, I wrote an hard-coded environment variable test user. These scripts which are running and preparing the machine and rebooting and something like this, looking at this variable, and this variable does the locking, is the locking mechanism at all. So if some user locking his machine, then it depends that every locked command is just done by the test user, which is named by this variable. And in this way, you can also have multiple keys, like Alexander has from his notebook and from his testing machines. They have different keys, and so he can use this feature. I, for myself, have the two. I have multiple machines with multiple SSH keys, and you can put the multiple keys in it, but you can give it the same username in front, so it's no problem to deal with this. The machines are pretty easy configured. There's just a directory called env in every home directory of every machine. And it's just contained files named machine, arch for architecture, IP, and the MAC address. And with this information, the install script knows how to configure the DHCPD, and how to configure the TFTP daemon to let the machines automatically boot over network. And if I want to plug a new machine into the infrastructure, I just copy this directory. I set up a new user, copy this directory, edit these files, and then I have a new machine with a new MAC address, and it just works. It's pretty convenient and easy to do this process. The only limitations I have is the amount of serial lines on one computer. So, but at the moment we have enough. It's okay. So the installation script you can run over SSH. It started via the nfdir program. It's a pretty nice program from DJB, as far as I know, and it works pretty easy. It's just you run nfdir, and after this, the first command or the first argument is a folder, and it reads the folder with the files, which are listed here. And after this, you give another command, which is this install script, and then all these files are then in the environment with their first line as content of the variable. And so the script knows on which machine, which architecture, which IP address it has to configure, and then the automatic boot system runs and make the auto install. What does the script also is, in the beginning, it loads the current pxeboot and BSD-RD file from the local mirror. It modifies the DHCPD config based on these files and the environment variable, the information from the home directory. Then reboots or cycles the machine. Reboot also runs over SSH. It is logs in as root user on the machine and run the reboot command. Or if it doesn't work, it just power cycles the machine. And after this, it looks at the serial output of the machine itself. And when it saw the machine run into the gratulation, your system is installed message, then it turns off the PX, the DHCPD boot, the network boot, and then the machine recycles and you get your prompt. The whole process costs about 7 minutes, 7 to 8 minutes, depending a little bit on the machine. And if you just type SSH machine at test lab install, it costs you 7 minutes, and you have a clean installed system with a current snapshot, and you can start testing your diffs. And to conclude everything, what do you get from this infrastructure? You have a clean current snapshot installed into 7 minutes. You have the current source code available via NFS. It's automatically mounted. The machines are installed with a site tar tgz file with where some pre-configuration is done. You have also on every installation you have the same host SSH keys, so that it doesn't annoy you when you connect in over SSH over and over again after installation, that you have to remove the old key and accept the new one. These are static, and these NFS configuration is static, and the interface configuration with IP address is static, so you just can start testing. Packages are also able to install from a local mirror in no time. It's just on the local network, so it's pretty fast to install the packages. And you can start debugging, and as I mentioned before, you have direct access to the serial console, so if you have a kernel diff and it panics, you can directly debug it, and when everything fucked up, you can plug the power switch remotely and put it in and retry. And I think this is for most cases what you need if you make a diff in the kernel level, beside of actual hardware development, then maybe you have to put your hands on. But for most other cases, if you have this environment, you can remotely debug everything and test everything on clean systems. At least I want to show some problems and then some future expectations or some future plans I had in my head, maybe which I would like to maybe implement. Problems we have some race conditions, so it's not, it works in general, but if multiple users would at the same time install several machines, it's not race condition free, because the pxeboot always runs the path /BSD on the machines and try to get them from the TFTP. And if you run multiple architectures or different versions of the BSD kernel, then you get in trouble, because maybe there's an ARM BSD file kernel to load, and some other user in a second later overwrite it with a new installation, and it's an i386 or it's an AMD 64, and so you can get it, in conflict. But if you install it in a reasonable distance, and it's okay. And if you just have few users, it runs for the moment. At the moment, there are 3 users. It's me, it's Alexander, and it's Patrick. Patrick does some ARM stuff, and there we got firstly into this problems that there are in the TFTP directory. There were some kernels laying around, which is not for i386 architecture, and the machines doesn't boot. So and this is a problem I'm working on at the moment. My future plans for the system to make it more usable. I got into interaction with or in discussions with other OpenBSD developers, where firstly more architectures, so that we can provide these infrastructure for other OpenBSD developers to have an easy access for other architectures which not everybody has in this home, or there's just a few developers, a few enthusiastic developers who have really many machines at home and testing on, but most don't. And so most don't care of if something break on other architectures. And to lower to lower the amount of effort you have to make to test it on Spark or on PowerPC or MIPS. I would like to provide this infrastructure remotely via SSH for other developers, so that they, if they had a diff maybe deeply in the kernel or so and don't know if it works or not, they have the ability to easily test it with this infrastructure. This is my main purpose at the moment, to provide this kind of service for the core developers. And ARM and Spark 64 we have in our lab. Thanks to MPI and Chris at OpenBSD, they sent me 2 machines, and PowerPC G5 system, which is to prepare to get into the system, and I guess I got from Chris, and MIPS 64 machine, which is also pretty interesting. So we have from the alignment perspective and from the strictness and the memory, we have a huge, good test coverage and good hardware coverage at the moment. And the next step is to integrate these systems. Patrick is working on ARM, and he has an own ARM machine where you can remotely debug on and developing on, which you use maybe just he at the moment. From Patrick, I got another requirement. He would like to remotely upload binaries. At the moment, he has root access on this machine, on the test master machine itself, and he'll log in and put his binaries in place in the TFTP directory, and boot them manually. And manually added the DHCP config. And I think it's more convenient if I find a way to give him access to just upload the file remotely and switch on and off the DHCP config per computer. And because in ARM it's at the moment not possible to make a whole automatic installation, because Patrick is working on initially get some boards, some ARM chips or socks working, and there you don't have a convenient auto installation. So if I implement some switches on this level, it would work for this work. It would help for this work directly on the socks. And the last idea which came me for Interactive is a mail interface, because the main OpenBSD workflow is there are people who are sending diffs on the mailing list, and a pretty nice interface would be to send mails directly or forward mails from TAG directly to the test machines, and they get automatically installed. The diff applied, a build, a regression test run, and if something in the chain failed, you get a reply which has the error messages in it, and it says, hey, see there, this doesn't run. Or if everything run, then you can just start testing on the whole diff as it is replied and as it is installed. And you don't have to fiddling yourself with installing machine and make all the stuff. So just type it in, and in 10 minutes you have your machine with diff, and you can test it by your own. Then just should be lower the effort of testing diffs, and maybe get some more progress on diff testing. Yeah, but this is summary for the future, which I may make during the next year or so. I will see. Yeah, that's my presentation. Have you any questions? Yeah.
Thanks. Cool stuff. You said you do the regress tests every night. That means you step up the machine, build the IPsec tunnels, do the performance tests, and then use your lab for other things during the day. The web page you said you showed in the beginning that you said you do some regression tests every day.
Yeah.
With that infrastructure.
With the infrastructure, I showed this is just the regression tests. Yeah, it's every night at 2 o'clock, I think, around 2 o'clock. A cron job running on Bloom starts the SSH commands to the test master. Then the machines get automatically installed. If it's finished, it runs the regression tests, and they're ready in the morning or so. Or it costs several hours. Or
it's 4 o'clock, 5 o'clock in the morning. And if something failed, I log into those OT1 to 3 machines and look what's going on. And the configuration for those machines, I've written the regression tests in a way that they can be pre-configured. Mm-hmm. So I've added the IP addresses I need. So for the path and view or IPsec tests, the packets run from OT1 to OT4, for example, the spin packet, and then it runs back. And between OT1 and OT2 it gets encrypted. All the configuration I put statically on there. And in OpenBSD there's a special install TG set. It's called site.
Yes, I know this, yes.
And there I put the configuration into it.
Yes.
And so they all, every day they get the same configuration and everything is set up. And just say, log into OT1 and say, make regress more or less in the special directory. And then it just runs.
Cool.
And at the end, I collect all the results to make this nice web page. Cool.
More questions here? Yeah, thanks for the talk. I wanted to ask you, we're also doing the network testing. We're doing the network testing, but in similar environments. And I want to ask if you consider to use IPMI interface instead of the power switch. We used the power switch before, but now we use IPMI because it eliminates lots of cables and a need to maintain another device, basically.
Yeah,
thanks.
I got asked about the IPMI interface too by other developers, but to be true, the machines we're running there are so old they don't have an IPMI interface. That's the reason. But for Spark and for newer i286 machines, you're right. IPMI would be a nice interface. At the moment, we are running good with these power switches. It's okay. But yeah, but you're right. There's a lot of cables.
Any more questions?